Hi mathematicians, this is Mr. Almeida. I hope you are doing well. In this video, we're going to learn how to add and subtract mixed numbers, okay? And as a reminder from the previous video, a mixed number is the sum of a whole number and a fraction that is less than 1, okay? So we call that a proper fraction, where the numerator is less than the denominator. So we are going to add and subtract these mixed numbers. The key to thinking about mixed numbers to make your computation not so complicated is to keep them as mixed numbers. Sometimes, because you know how to do this now, sometimes you might feel tempted to rewrite this mixed number as a fraction, but it actually is going to give you really large numbers, and when you end up doing your computation, it's going to end up being maybe triple-digit divisors with 4-digit dividends, so you don't want to have to deal with those big numbers. So to keep things simple, keep your mixed numbers as mixed numbers when you are adding or subtracting them, okay? All right, so how do we add or subtract mixed numbers? First, let's deal with adding mixed numbers. How do we add mixed numbers? Well, very similar to how when you add whole numbers, you add the ones, then you add the tens, then you add the hundreds, then you add the thousands. You're going to add the smaller units first. And in this case, it's going to be the fractions, okay, that are proper fractions. So we're going to add the fractions, and then we're going to add whole numbers after that, okay? So start with your smaller units, your fractions, and then your whole numbers after that. And that's all there is to it. Now, let's get into adding mixed numbers. All right, the first thing that we need to remember is when we're adding or subtracting mixed numbers, or adding, subtracting anything, we have to make sure that we have the same unit or the same denominator. So what operation are we doing? We are adding. So we ask, do we have the same denominators? No, we don't. But we can make them have the same denominators by multiplying both the numerator and denominator by the same number. In this case, that same number is going to be the other fraction's denominator, okay? And we can do this because we're making equivalent fractions. And equivalent fractions theorem says if you multiply the numerator and denominator by the same number, or you divide the numerator and denominator by the same number, you'll get an equivalent fraction. We're going to apply that right now, okay? All right, so we're going to rewrite this mixed number, 7 and 2/11ths, with an extended fraction line so we can actually rewrite an equivalent fraction and to this mixed number. Then we're going to add 5 and 9/10ths with an extended fraction line to make an equivalent fraction to this mixed number. All right, what are we going to multiply both the 2 and the 11 by? By the other fraction's denominator. So we're going to multiply both the 2 and the 11 by 10. So we do that. Multiply by 10. And then to make an equivalent fraction for this mixed number, we're going to multiply both the 9 and the 10, both the numerator and the denominator, by the other fraction's denominator, which is 11. So we multiply both the 9 and the 10 by 11. All right? Now we rewrite what the equivalent mixed number is down below on this next line. All right? So we have 7 and, what is 2 times 10? 20 all over 11 times 10, which is 110. So we have 7 and 20 110ths plus 5 and 9 times 11 is 99. So that's the numerator, 99. And we know that 10 times 11 is already 110 because of the commutative property. 11 times 10 is the same as 10 times 11. All right, so we have our equivalent mixed numbers now to the original mixed numbers. Okay, that means they're the same point on the number line. It's just the symbols look different so that we can compute with them. And we ask, do we have the same denominators now? Yes, we do. So we can add. Let's add our fractions first, okay? Add our fractions. So we add our fractions, and we have 20 110ths plus 99 110ths. We know that they're going to have the denominator of 110, so I'm just going to add up the numerators. So 20 plus 99 is 119. So I have 119 100/10ths, okay? All right, so now I added up my fractions. Now it's time for me to add up my whole numbers, okay? So we have 7 plus 5. 7 plus 5 is 12. All right, so I have a whole number and I have a fraction. Is this fraction a proper fraction? Is it less than 1? Is the numerator less than the denominator? No. So I have to rewrite this fraction right here as a mixed number. So remember, what's going on here is there is an invisible addition symbol right in between the 12 and this 119 100/10ths. So I am going to make it visible and write 12 plus, and now I'm going to figure out what 119 100/10ths is as a mixed number. To do that, we divide the numerator, which is 119, by the denominator, which is 110. And I put these little blanks up here to let you know that we have that we're supposed to have 3 digits for this, just so you put the digits in the right place. All right, how many 110s are there in 1? 0. So we write a 0 up here. You can do 0 times 110 and subtract that from 1, but you're still going to end up with 1. All right, so then we are going to ask how many 110s are there in 111. I'm sorry. How many 110s are there in 11? There are 0, so we write a 0 right here. How many 110s are there in 119? There is 1. So 1 times 110 is 110, and we subtract that from 119, we get 9. So what is our mixed number? 1 and 9 100/10ths. So let's write that. 1 and 9 100/10ths. All right. Now do I have a mixed number here? Yes. All right. So I added up my fractions before, then I added up my whole numbers, but then I had to rewrite this fraction as a mixed number. So now I have to start all over again, okay? I have to add up my fractions. Well, there's only one fraction here. I have 9 100/10ths plus no 100/10ths, or 0 100/10ths. So that's going to be 9 100/10ths. And then I add up my whole numbers, and 12 plus 1 is 13. And I get 13. And that's it. We're done. Okay? So that is how we add mixed numbers. Okay? And now we're going to talk about how we subtract mixed numbers. Okay? Before we get in there, I just want to reiterate this. When adding or subtracting mixed numbers, keep them as mixed numbers. Your computation is going to be a lot easier if you do that. Okay, so we're subtracting mixed numbers, and how do we do this? Well, just like we did with addition, we're going to do with subtraction. We're going to subtract the fractions, that is the smaller units first, and then we're going to subtract the whole numbers after that, okay? Now, when you're subtracting fractions, if you are unable to subtract the fractions, you unbundle a whole unit and rename the fraction, okay? Now, it's very similar to when you're trying to subtract, let me just write it right over here. It's very similar to when you're trying to subtract 21 minus 15. You are trying to subtract 5 ones. Do you have at least 5 ones? No, so you're going to unbundle a 10. How many 10s remain bundled? One of them, because you only took apart 1, and there were 2 to start with. And each one of these units is worth 10 of these units. So 10 plus 1 is 11. So we cross out this one and write 11. Now, do you have at least 5 of these units to subtract? Yes. Do you have at least 1 of these units to subtract? Yes. So now you can subtract, okay? So it operates in the same exact idea as whole numbers, okay? This idea when we're trying to subtract and we don't have enough fractions to do so. This is if we're trying to remain positive, okay? All right, so we are subtracting mixed numbers, and we ask ourselves, do we have the same denominator? No, we don't, so let's make them have the same denominator, all right? So we are going to multiply both the numerator and denominator by the same number, make equivalent fractions. In this case, it's going to be the other fraction's denominator. So we'll rewrite each of these mixed numbers with extended fraction lines to multiply both the numerator and denominator by the other fraction's denominator, which is 10. This is if you want to make the fractions have the same denominator. And we'll multiply both the 9 and the 10 of this fraction by the other fraction's denominator, which is 11. Now, let's rewrite. We have 7 and 2 times 10 is 20, all over 10 times 11 times 10, which is 110. So we have 7 and 20 100/10ths minus 5 and 9 times 11 is 99, all over 10 times 11, which is 110. So we have 5 and 99 100/10ths. All right, first thing we're going to do is we're going to subtract our fractions. We're trying to subtract 99 100/10ths. Do we have at least 99 100/10ths here? No, we don't. So we are going to unbundle one of these whole units, okay? Now, in this case, we know that one whole unit is equal to 110 100/10ths. So whatever your denominator is, you're just going to say that same number for the numerator, because 110 divided by 110 is 1. So you broke a unit up into 110 equal parts. How many of those parts do you have to take to get to one whole unit? You have to take all those 110 parts, okay? So it's 110 100/10ths. So when I unbundle one of these wholes, it's going to be 110 100/10ths. And what is it being added to? 20 100/10ths. Okay, now 110 100/10ths plus 20 100/10ths is 130. That's 110 plus 20, 100/10ths. Okay, so I'm going to rewrite that so I took apart one of these whole units. How many whole units do I have left over or bundled? I have 6 of them, okay? And then another name for one that I unbundled, and 20 100/10ths is 130 100/10ths. So I write that right here. Minus 5 and 99 100/10ths. Okay? So now I ask myself, I haven't subtracted fractions yet, let's do that. Trying to subtract 99 100/10ths. Do I have at least 99 100/10ths? Yes, I do. So off to the side, I'm just going to do 130 minus 99, though some of you who are doing mental math can figure it out. I ask myself, I'm trying to subtract 9 ones. Do I have at least 9 ones? No. So I'm going to unbundle a 10. How many 10s remain bundled? 2. Each 10 is worth how many ones? 10. So I'm going to add 10 to this 0 right here. 10 plus 0, right there. All right, do I have at least 9 ones here? Yes. I'm trying to subtract 9 of these units right here. Do I have at least 9 of them? No. So I unbundle a unit to the left. How many units remain bundled after I have 1? 0. And 10 of these units plus 2 of these units is 12. Okay? So you can either write the 1 in the front or you can cross it out and put the 12. All right, now I have what I need. Let's subtract. 10 minus 1. 10 minus 1 is 1. 10 minus 9 is 1. And then 12 minus 9 is 3. And 0 minus 0 is 0. So we have 31. So 130 100/10ths minus 99 100/10ths is 31 100/10ths. So I subtracted my fractions. Now it's time to subtract my whole numbers. What is 6 minus 5? It's 1. And that's it. We're done, folks. That is how you subtract mixed numbers. So I hope that you fully understand how to add and subtract mixed numbers. If you have any questions or still not quite sure about it, I recommend going back and rewatching the video, maybe pausing it at the time when you're quite not sure as to what's going on, and just look at the screen and see what's going on for yourself. Sometimes the speed at which the video is recorded is a little too fast, and so just rewind it, pause it. There's also a way for you to make the video slower so that you can hear my speech at a slower pace. At any rate, I hope that you enjoyed this video. I hope that you get better with adding and subtracting mixed numbers, and I hope you have a great day. Take care, folks.